So presumably, if you're here, you are all potentially interested in Malformity. This is the first talk today that uses or is focused primarily on using Maltigo. There's another one after this in track 1, I believe. Some basic info. Got my bachelor's and master's in IA from Norwich University. I'm not from here in Vermont. Background in forensics and incident response. I started out in .gov, got out of there pretty quick. Went to MSISAC, which is Multi-State Information Sharing and Analysis Center. Some of you may be familiar with the other various ISACs for several different industries. And now I am a member of the Verizon Risk Team. I'm very happy that data breach report season is over for the time being. And then primary author and maintainer of Malformity, which is what I'm presenting today. Most important piece on this slide: all opinions are my own. Do not reflect or represent those of my current or previous employers. Quick overview. I'm just going to do a basic what is Malformity. Before I start that, how many people here have used or use on a regular basis Maltigo? Okay, pretty good. How many of you are familiar with Canary? Great. So also a few notes. Maltigo, produced by Perturba. The guys at Perturba are great, and it's a great product, and it is not all that expensive considering how expensive a lot of commercial products do get. So if you're using it in a commercial capacity, please buy a license. Canary is developed and maintained by Nadine Duba. If you ever run into him at any conferences, feel free to buy him a drink. Special thanks out to Ode. Included his entity packs, which we'll get to later in Malformity. And like I mentioned, David Bressler has a talk after this one on using Maltigo in the enterprise. So Malformity is a local transform package for Maltigo developed using the Canary framework to assist in gathering data about malware and malicious infrastructure. But what does that actually mean? So starting from the beginning, a bunch of you already know. For those that don't, Maltigo is an open source information gathering tool. A lot of people jump straight to an open source intelligence tool, but I try not to use that because collecting data does not automatically turn it into intelligence. If you're not doing analysis on it, it is not intelligence. So this tool can help you collect it, can present it in such a way that you can do analysis on it, and in that way it may help you produce intelligence based on the data collected. You can collect this data on several things out of the box: websites, companies, network infrastructure, social media accounts, a vast array of standard features. It's cross-platform and customizable. You can run it on Windows, Linux, OS X, and Actual C can be customized. And then it provides a very nice GUI that will give you a graphical representation of the links between the data that you collect. So when you generate things like this, in certain new companies, management may get really excited about that. There are a few building blocks within Maltigo that everybody needs to understand for the rest of this. The first are entities, basic things like a company, IP address, domain. It would be those things over on the right. Each of those is the basic building block, represents essentially one piece of data on the graph. So transforms are then used and applied to entities. So this will take in one piece of data, do something to it, and return another piece of data. In some cases, it may not return a new entity, it may alter the current entity. Common ones: if you have a domain, pull back, go out, variety of methods, grab an email address associated with that domain. If you have an IP address, grab all known domains associated with that, et cetera, et cetera. And then a newer aspect are machines, which are used to run multiple transforms at one time. So I like to think of these as kind of moving closer down the stack. Instead of pulling every piece of information separately and maybe doing some analysis to tie them together, you can kind of use machines to skip, if you have a common task that you do a lot, for instance, say you want to go from an IP to a domain and then to all the IPs previously associated with that domain, instead of having to essentially run 2 transforms, you can run them in a chain, do it both at once, and you're going to generate more data points on your graph quicker. Now these come in 2 basic flavors, and that's macro, which is a one-time run. You can create a machine, select 1 or more entities, and then run it once. Or they have timed machines, which are good for automatically updating data. So for instance, if you're pulling somebody's Twitter feed, you can create a timed machine, and then on a regular basis, pull any updates to throw into the graph. So a little bit more in-depth for the transforms. You have local and remote transforms. Malformity, using the Canary framework by default, is a local transform package. Now there are pros and cons of each. Naturally, they are somewhat inverse of each other. Pros for the local transforms, you get complete control over what's run. If there's an error, you can change it or edit it immediately on your box. They're machine specific, so if you're using a service that is limited to originating from a specific IP or is otherwise restricted, you can tie it to local aspects of the box it's being run on, and they're language independent, as with the system operating system independence. The local transforms can be run in Python, Ruby, Perl, basically anything you name it. Cons: if you have a package with a lot of dependencies, every one of those dependencies has to be installed on every box the transforms are installed on, which leads to version control issues down the road with updating, which then can lead to missing features. If a transform in the package is updated and not everybody using that package has updated it, you then have some people that may not be running the most up-to-date feature set. And then data sensitivity. With the local transforms, if you're using something that uses an API, then that API key is going to have to be on every box that the transforms are on. So in some instances, this obviously isn't ideal. Same thing goes if you're using something that requires any type of credentials. You may not want to store them on every user box that may be using this. And then kind of opposite for the remote transforms, a lot easier. Anybody can configure the remote transform server, and then it automatically finds all the transforms, and the user basically doesn't have to worry about them, which results in universal updating. You change it on the server once, it automatically gets pushed out to all of the clients. And then there are some features on the remote transforms that aren't supported for local transforms. In my opinion, the biggest one that causes the most issues is limiting the number of results that you get from a transform. If you're running a local transform, this for me, most often happens when I'm pulling passive DNS. If I use an IP that is a hosting provider and I pull passive DNS, my graph dies. You're going to get 10,000 results, and you basically have to wait until it populates, hope that you can select all the results and delete them all. If you're running a remote transform, Maltigo has a built-in capability to support a limit. So I could say I only want 200 results max, or for this transform, I only want 20 results. Cons: different type of data sensitivity. If you don't own the server, the transform server, or the network you're on is going out over the internet, everything that you are looking up is getting sent to the transform server. So if the entity itself is sensitive, you would not want to send that out to the transform server if you don't own it. Single point of failure: if the server goes down, there could be potential issues with connectivity for updating, or if you have a new client coming on with grabbing the transforms. And then integration and control, it's harder. If you're using a service that is rate limited, then coming from a single API, or sorry, a single IP for that one API, and you have a bunch of people using it, you're going to run into issues quicker than if each one is running a local transform. I know VirusTotal does this, especially if you are using a community account. It's a 4 per minute limit. If you're running 4 people off of one IP from one server, then you're going to have a hard time doing VirusTotal analysis. So then a little bit more in depth with machines. Besides being a one-time run or a recurring timed run, you also have serial and parallel machines. And essentially this allows you to run multiple lines of execution with the same machine. So with a serial, say I had an input entity of an IP address, it would first run all of this block. It would run the first transform, the second transform, and you would end up with a resulting entity. Now there's also going to be entities returned in here from each of these. The biggest thing for machines is that you have to make sure whatever transform it's going into can accept the entity returned from the previous transform. Now, so like I said, in this example, these are going to be run, and then it's going to go back to the original input and run this stack. Now, with the parallel, it's going to run both transform A and B, and then on those results, it will run transform D. So the big catch with that is you have to make sure transform D is applicable to the resulting entities from both A and B. If that does not, if transform D isn't applicable to what's returned from A and B, you can run into issues. Although Maltigo is pretty good when you're editing machines in the editor, it will tell you if it's invalid. Now, this doesn't necessarily mean if you have, like I have some transforms in Malformity that will return more than one type of entity. Now, there are also filters in machines, so if you have something returning more than one entity, you can say, okay, throw this one away and keep just this one. It allows you to customize it a little bit more and get different lines of analysis. Moving on to Canary, is a framework for transform development. If you start developing transforms or other types of entities or machines directly in Maltigo, if you don't do it in the GUI, it is not fun. They use a lot of XML, and doing the development on large scale outside of the GUI basically becomes a pain. They provide some tools to deal with it, but it's still pretty labor intensive compared to using Canary. It's cross-platform, that way it works on everything that Maltigo works on. It does support remote transforms now. Malformity is currently a local transform package. One of the goals you'll see later is to convert some of the local transforms to remote transforms. Others basically won't work as a remote transform. Multiple language support, so you write whatever you want. And what does that mean? Simplifies development, distribution, and installation. If I have local transforms that I want other people to be able to use, and they're not using something like Canary or Canary, then every one of those transforms has to be installed into each Maltigo client. With Canary, I can run one command and they all get installed at once, along with any entities and machines in the package. So it's a one-stop process. And basically that means Malformity, and there were several other projects using it now at this point. The original that was the predecessor to Canary was Maltigo. I'm not sure if anybody has heard of that. Also developed by Nadim, and that was presented at DevCon a couple of years ago. So moving on to Malformity itself, the name, Malware Transforms and Entities, that was prior to including machines, so that's what's stuck. It's a collection of transforms to assist in conducting the analysis, and currently these are probably the best. There may be one or two others, but these are most of the ones represented. The biggest build out at this point is VirusTotal, just because their API is really easy to use and they return really useful data. Also, the ISC passing DNS, there are quite a few transforms. The others, like the team timer hash check, basically it'll check, it's not going to return an entity, but it's going to update the entity to tell you whether or not it was detected in the Kangaroo database. And then things like malcode, VI check, threat expert, they can pull back additional information if the samples are in their databases. This is the portion I was talking about that Canary simplifies. Install, basically, you git clone project, create a directory or change into the directory, and run the Python install. That will take care of all the dependencies. There aren't too many at this point. I think there's actually more for Canary than there are for Malformity. Right now, one hitch with the dependencies is that previously the newest version of Canary could be automatically downloaded and installed, but that is not currently available through the normal easy install methods. So you would have to also git clone Canary from the GitHub repo. And I have a link for that at the end of the presentation. Very important point, if you're setting this up for the first time and you have not used Maltigo on your system, you must start Maltigo and initialize it before installing Malformity. Otherwise, the environment that it sets up is not going to be initialized and the install will not work. Once that's done, basically this is it. Canary install package Malformity, and all the transforms, entities, etc. will be applied to your install. If you have been using more than one Viterbo product, a little prompt will come up and say which one do you want to install it to. And then something like this will show up on the command prompt. And within Malformity, you'll then have, or within Maltigo, you'll have access to various transforms and entities that you can view with either of these buttons in the top control bar. And if you see those, then it is successfully installed.
No questions now, or the
Either.
on the malware hash, which hash does it use?
So the virus tool was going to accept anything the virus tool accepts, which is MD5. Basically, they accept all of them. Most of it is source dependent. By default, I try to return MD5 values just because those are the ones accepted everywhere. Right now, the virus level transforms are returning the default /56, I think. However, I was told there's a way to force the API to return MD5s instead of those. So I'll probably be implementing that on those so that it's consistent. But the entity itself can accept any. So some example use cases. The first one, individual hash lookup, depending on your daily day job, maybe any various number of reasons that you'd like to get some more information about any particular binary. So just an example, in this particular one, an easy button may kind of be all transforms, and then that'll just go run them all. The problem occasionally that you're going to get is if there's a lot of results, you may not know which results came from which portal, if you care. I prefer to go source by source. And then occasionally, if I know there's a good chance that one of them is going to return a lot of entities, I will try something else from that source first, just to see if it's present. And if it's present in that source, I will then run all of them, all the transforms from that source. So in this case, this hash was present on Threat Expert, and the example goes from a hash entity to two different types of resulting entities. You have a URL and a phrase. Now these phrases are actually mutexes. I don't yet have a mutex entity. So those are what I was able to successfully pull from the Threat Expert report. Now, looking at these, we don't necessarily know. Yeah, it's a no IP. And probably most businesses don't want dynamic DNS services. And the mutexes look kind of funny. In this case, there was some other information available on the report that I don't have transforms for at this point. So that was the only source that hash was present in. So if I go directly to that site, I can also take a look real quick and see that the register keys match some of the mutexes. Probably don't want extreme rat running in your organization, and give you some more information to go look for. Now the biggest thing here is that cut down, I got this hash initially. If I don't have an internal method of doing it, I don't then have to go search VirusTotal, then go search malware, and then go search Threat Expert. I can run them all real quick here, figure out if it's present in any of them, and if it is, I can go directly to the one that's present in. So basically a big time saver. Use case 2, going for a network piece of information. In this case, it's a domain. I'm going to run and see the two domain transforms I have for VirusTotal at the moment are using their newly introduced passive DNS feature. In this particular case, this one is scraping the web results, so you do not need an API key to use that one. The domain search, you do need a private API key. because it uses the API search functions. So if I search that domain, these are the results I get. Right off the bat, then yeah, if there's that many samples in VirusTotal communicating with that domain, there's a good chance it's bad, but we're going to go ahead and confirm. Want to know what it's recognized as, what it's detected as. So I'm going to select, because there were so many results, I wouldn't normally select all of them in this case because there's a good chance they're related, and it's going to kind of clutter if I select all of the results to run. But if I go to malware name down at the bottom, and this uses the publicly available API, the community API, so it's limited to 4 per minute. But we did that so that you didn't have to have a paid API key in order to use that. In general, I try to keep anything free that I can. If it's a function only available in the paid version, then obviously that's what I have to use. But if it's something that's available in both, I try to go with the free one so that more users can use it. And so probably doesn't require a deep dive. Most of the detections you can see are pretty general, but the middle two there, good chance it's some kind of adware gaming type of malware. So if I wanted to get some additional indicators to look for, I know that I have this. Depending on how you got it, you may not have them offhand. Running one more transform on the same, or selecting another random state of hashes. I've got the user agents, the port it's communicating on, what IP address at the time of those reports, and the URL request. And in this case, the different samples were using different user agents, so there's a couple others on the other side. Use case 3, my personal favorite, and the one I use this for the most, is threat tracking and mapping. So basically, assume we start in this case with one verified domain. A lot of times that's probably not going to be the case. You'll probably start with more, or you may start with something that's unknown. So I'm going to take that domain and real quick use the passive DNS to see what IP addresses it was associated with in the past. In this case, we have only 2 that somewhat limited, but results nonetheless. I'm not sure if anybody in the room recognizes that top level domain. One thing that was can't really see it on this screen, but this right here, real faint outline, are dates of first seen, last seen for that IP and that domain. However, if I take those 2 IPs and I continue, you can occasionally get carried away. This is primarily just passive DNS results starting from that first domain. A lot of people may say, wow, that's really cool. We know all the IPs and domains used by whoever was using that original domain. However, you should not assume results from any of your transforms are infallible, especially when dealing with network type information. It should be an iterative process when doing that type of analysis. Basically, building in other data sources is one thing that I would highly recommend. So that graph was primarily IPs and domains. Now, you're going to get a lot more, corroborated links when you start building in things like email addresses that have registered those domains. When you start building in malware samples that are known to communicate with those domains, and then groups of those malware samples may then share similar characteristics. So you're going to get more defined groupings as you build more different entities in. The biggest thing is watching out for false positives. If you get an entity that returns a ton of results, especially with passive DNS or other network data, you're going to get sinkholes on the graph, guaranteed.
Can you put date range parameters on the passive DNS?
That is one thing that I have. I have a script that does it. It is not currently a transform. I want to. The primary issue is it's not done sending it out to the request.
Right, it's
It's,
post-result.
yeah, so it's going to have to pull them in. It's basically the increased processing time. So it's going to pull them all in, and then based on what it finds, only select them. But that is something that people have asked about before, and I do have on the roadmap. It's something that, like I said, I have a script for. I just need to port it over to a transform. You're going to get parking pages, especially common with a lot of malware. If you all of a sudden get multiple either types of malware that's attributed to different sources, anything like that, that all points to the same IP, make sure you do some research on that IP, because there's a good chance that it's going to come up to a standard DS parking page, or it's going to be a Google IP or a Microsoft IP. And those are ones that they may be interesting to know as far as if a specific group or entity uses the same parking IP over and over. But for the purposes of your graph and generating more information and further research, it's going to make that harder. And then there are other random abnormalities that just once in a while something will show up that doesn't really apply. A lot of times you'll need to weed out results that you want or don't want. Again, that goes back into being an iterative process. So future development plans. Right now, it's primarily transforms. I have a list of machines that I'm working on that I want to get running to automate common analysis steps. And that kind of, like I said earlier, moves one step closer to generating intelligence versus just data. However, it still does require analysis. It's not going to be a one-stop answer. Building out additional host-based and local network transforms. The one big area that I want to move into with this package is actually doing binary analysis and graphing the results in Maltigo. So one example that I'm probably going to move or start with, I guess, on this front is something like PyU, which is a Python package for some basic static analysis of binaries. Give it a hash or file name. Essentially go out, run whatever particular commands using the PyU on the binary, and then returning the results on the graph. I don't know if that's going to turn out beneficial. My theory is that with certain families or groups of malware, you would be able to see correlation among a lot of the information returned, and that's one of the areas that I really want to move into and look at. However, with those host-based ones, obviously you have to have the binary available. Those are not good candidates for remote transforms just because of what they're doing. Along the same lines, integrating it with other analysis tools specific to malware analysis could be another route. I would like to include more vendor tools and APIs. Biggest catch with that is if I don't have access to it, then it's hard to develop for it. So especially if I get a request from somebody, I am more than happy to develop the transforms for whatever product or API they're using. The catch is they have to give me access to it, because otherwise, unless the particular vendor has extremely good documentation and they are willing to test it, then there's not much I can do. And then building out the web sources. New sources, if anybody has suggestions for new online sources for malware or network threat intelligence that are widely available, shoot them my way. Would be very grateful. I want to get this applicable to as wide an audience and as useful as possible. So as long as I can gather more sources, I have a couple in the hopper that I'm working on, like instead of just ISC passive DNS, there's Firestore right now. Also have a transform testing for Circle, the malware, or the Luxembourg cert. They have a passive DNS service that you can get access to if you apply for it, but it's not paid access, so more people have access. And then biggest thing, community suggestions. You know, I'm going to keep going in things that I would probably use, but I would love to develop based on what the community and users of Malformity are going to use. That makes it most useful. I get more testers, biggest thing, a lot of the web scraping ones, if this happened recently, I had MALWR, malware, run by the guys that put out Cuckoo. I had a bunch of transforms for that, and they just changed their web interface, and obviously kills them all. That, I found that out before prepping for my last presentation, so that kind of put a kink in things. I hadn't used them for a couple of weeks, and that was the time period it changed. So the more feedback I get, the better. It's usually things get fixed faster. Happened last week. There's a few VirusFlow ones. VirusFlow was changing up some of their web interface, and there was a couple there that stopped working. Got those fixed right off. Like I said, if people are using it and send that feedback my way, it's easier for me to get it fixed and pushed out. The links I was talking about, the Git repo for Malformity, Maltigo if you haven't used it before, Canary. The project forums are a great place to go if you have any questions about any projects using Canary, are trying to develop for Canary and have questions, or are having issues with install. Basically, it's supposed to be a one-stop shop. So there's a Malformity forum within those forums to post any questions, or GitHub issues are great, emails are great. Basically, I'll accept it whichever way you want to send it. And I had a quick post here on my blog about installing Malformity, a quick walkthrough to try to hit some of the important points that can be stumbling blocks for the install. And I hope people have questions. These are the various methods to contact me or look for additional information. Offhand, does anybody have anything they think would be a good candidate to include that is not already in Malformity?
URL query?
Yes, that would be. I got it. As long as the biggest thing with the web sources is if they randomize their URLs for grabbing reports, it makes things more difficult. However, if there is a search function, it's still doable using Mechanize and a few other the Python libraries. So I think you can easily search in URL query, right? So that should be still doable without any issues. Any others? Curious about. I've had, I think, one request for some reputation services, and I think that's where kind of the Kaimaru hash check falls under that, and the Bit9 file advisor is a yes or no answer from a reputation service worthwhile. Is basically if I want to submit something to IP void or URL void, are those results interesting? Okay, and that's one thing I was curious about as far as people using if being one stop, if they want to get information and just immediate results. It's good to know. Something
helps thinning out a big graph.
Yeah, definitely. Any other questions, comments? Feel free, like I said, reach out any method up here, and if anybody has any questions, feel free to come up and talk to me after. Give you a couple minutes of your time back to enjoy this lovely afternoon.